Okay, so going ahead, we're going to talk now on the F test. Okay, so the F test is what we call an overall test, a hypothesis test of the regression. The test has a hypothesis, which is that every single slope, beta 1, beta 2, up to beta k, all of those, the null hypothesis is that all of those are zero, meaning none of the variables is a good predictor. And the alternative is that at least one of them is a good predictor. At least one. It might be that beta 1 is actually different than zero, or it might be that beta 1 and beta k are actually both different than zero, meaning that those two predictors are good predictors. But the test is set up that way. Again, the null hypothesis is none of the predictors have a slope that is different than zero. All of them are not good, in other words. Versus the alternative, at least one of them is different than zero. Or at least one of the slopes is different than zero, meaning that that predictor is good. So the test statistic for that is actually the explained variation, the total SSR, summing up all the SSRs. If you have the ANOVA output in R, remember that R gives it broken down by predictor. So you would have to kind of sum up all of them and divided by K, which is the number of degrees of freedom for SSR. And then that is divided by the unexplained variation SSE divided by its degrees of freedom. So you have here the formula for getting that F statistic. And in the language of the problem, what this means actually is, well, how many times is the explained variation more than the unexplained? It's a ratio of explained to unexplained variation. So if that number, that F statistic is 10, what it means in the language of the problem is that, well, the average explained variation is about 10 times higher than the average unexplained variation. So the nice thing of that F statistic is that it has a distribution. As long as the assumptions of the regression model are met, and remember what those assumptions are, then the F statistic behaves as an F distribution with k degrees of freedom in the numerator and n minus k degrees of freedom, n minus k plus 1 degrees of freedom in the denominator. So just to remind you what the F distribution looks like, it looks like a skewed to the right distribution that starts at 0. So for instance, for example, if the F statistic is 10, remember the meaning? The explained variation is about 10 times as much as the unexplained. But we have to kind of know whether that is significant. We can't really know if 10 is good or if 10 is bad. It depends on the problem, it depends on the number of observations, and it depends on the number of variables. So it depends on many aspects. So because the F distribution has two different types of degrees of freedom, then we would have to know the F distribution with k degrees of freedom in the numerator and n minus k plus 1 in the denominator, and then we can compare it to these. Then we would know what is the probability that we would get a value that large. So that is shown in the summary of the regression. That F statistic right there tells you that the average explained variation using these two predictors is about 120 times more than the unexplained. And then we have the degrees of freedom in the numerator, which is k, number of predictors, and then the degrees of freedom in the denominator, 29, which is n minus k plus 1. So in other words, n minus 3. So just to be clear, n is going to be 32 in this case. So in order for us to get a p-value for that, we would have to just compare it to something, and that would be f with k and n minus k plus 1 degrees of freedom. So if we know that, then we can get that probability from any software, any statistical software. So the p-value tells us, well, what is the probability if the null hypothesis is true? Remember, the null hypothesis for the F test is this. The null hypothesis is that every beta, every slope in this case, is equal to 0. So the slope for H and the slope for number of bits both are equal to 0, meaning neither H nor number of bitters are good predictors. If this is true, what is the probability that I get an explained variation average explained over average unexplained variation ratio of 120 or more? That seems unlikely. The unexplained variation, if it is 120 times more than the unexplained variation, what are the chances that this is still true, the null hypothesis? And that is very low. So we would have to reject this and say we conclude that at least the alternative is that at least one of them, maybe H, maybe number of bitters, or maybe both, but at least one of them has to be a good predictor because this p-value is very low. Again, that is the concept of the F statistic. The F statistic measures the ratio of the average explained to the average unexplained variation.